Hi, I'm Alex from the Zscaler Customer Success Engineering team. In this series of short videos, we're taking a look at the baseline recommendations for the configuration of Cloud Firewall inside Zscaler Internet Access. This is part 2, Understanding Cloud Firewall. Let's start by taking a look at what the Zscaler Cloud Firewall is capable of doing. Cloud Firewall's inline proxy architecture allows it to perform user context and risk analysis, as well as device posture analysis, to understand application context and location context, and to provide IPS security and DNS control and security. These elements combine together to allow for the same set of policies everywhere closest to the user. In addition, firewall logging provides complete visibility over non-web traffic. Unlike traditional firewalls that rely on appliances that must be purchased and installed in order to scale your capacity, the cloud firewall has unlimited scale. With that said, it's important to understand that the cloud firewall is an outbound firewall. It primarily sits between the users and the internet rather than the other way around, and will not serve for network functions such as remote access or site-to-site VPNs. Finally, it's important to understand what traffic is subjected to cloud firewall policies. In the context of traffic forwarding methods, sending your user traffic to the Zscaler Zero Trust Exchange. If your forwarding method is using PAC or zTunnel 1.0, firewall rules will only apply to web traffic. If your forwarding method is GRE IPsec or zTunnel 2.0, firewall rules will apply to all ports and all protocols traffic as long as it is forwarded to Zscaler. Web traffic sent to Zscaler data centers via PAC or zTunnel 1.0 can still benefit from firewall policies. For example, blacklisting IP addresses requires firewall rules. URL control policy is not triggered if a user attempts to directly access an IP that maps to a blacklisted FQDN. Firewall rules also allow country-based blocks, and it's important to understand that firewall control rules are needed if SSL inspection is required for a non-standard port. With these limitations and considerations in mind, let's take a quick look at the architecture involved. First, a reminder. Zscaler users connect to Zscaler public service edges, which are themselves connected to a central authority, which makes sure that the public service edges apply configured policies to your users. The architecture inside a service edge looks something like this. This is obviously a simplification. The important information to retain here is that the Cloud Firewall module is the first module applied before the proxy module controls. Next, let's take a look at what the Cloud Firewall module is capable of in some more detail. First, it's important to understand that the Cloud Firewall module possesses granular policy control. In this example, we've created policies that allow only HTTP and HTTPS traffic for users on the guest Wi-Fi network, that allow FTP file transfers for IT users only, that block all P2P apps except for Skype for Business, and that allow access to dynamic IPs based on FQDNs for specific users and specific destinations. Something that's important to understand is the firewall control policy logic. Firewall rules can be created as AND rules or OR rules, which is based purely on correct combinations. In this example, Telnet is selected as the network service, predefined as a network service on port 23, and we are selecting Telnet as the network application. So in this case, it is an and Telnet will only work if it's on port 23. If traffic is Telnet but on another port other than 23, this rule will not trigger. Logically, you would create another rule either as the default any block, or one that specifically blocks Telnet as an application that would come after this rule. It's worth remembering that you shouldn't combine big lists of network services with big list of network applications in a single rule. That would present too many AND possibilities which would never be met. Another capability of Cloud Firewall is the ability to control non-standard ports and take the appropriate action. Via deep packet inspection, Cloud Firewall is able to cache non-standard ports on which web, FTP, or DNS traffic are detected. This allows it to identify evasive traffic on non-standard port, and redirect that traffic to the right module to apply DNS control, perform TLS inspection, or send to proxy. For remote users, the Cloud Firewall policy engine simplifies policy definition and application by the existence of the remote user policy object. This appears as the road warrior location in the list of locations to which firewall policies can be applied. Through this, you're able to easily assign policies to work from anywhere users, ensuring that you have a firewall policy that is consistent for all users everywhere all the time. From a reporting perspective, it's important to understand that the capabilities of the standard Cloud Firewall and the advanced Cloud Firewall are quite different. For the standard Cloud Firewall, the firewall dashboard will report on top network services, top locations, and top blocked rules hit. The advanced Cloud Firewall dashboard will provide a drill down per application for top applications, top blocked users, rule name hits in every log, as well as a customizable displayed field selection. Also important to note is that Cloud Firewall management is possible via APIs. This includes full CRUD for all cloud firewall rules, objects, and entities, and full documentation with examples. This makes it easy to build and manage firewall policies at scale via APIs rather than relying on the admin console. Finally, to conclude this video, a quick reminder of the difference between standard and advanced cloud firewall. For standard firewall, the main limitation to be aware of is that only 10 firewall filtering rules can be created. In addition to these firewall rules, FTP control, NAT support, and support for fully qualified domain names and policies, advanced cloud firewall adds DPI-based network application identification and awareness, user awareness, allowing the creation of policies that are granular based on user, group, department, and location, DNS control, including DNS as a service, access control, and DNS security against malware, phishing, and DNS tunneling, IPS control, including granular policies for intrusion prevention and protection for all ports and protocols, and real-time logging with full log visibility in seconds. That's it for this video. Thank you for watching.